Hello everyone, I am thrilled to welcome you to this demo class on electrostatic, a fascinating area of physics that deal with the study of electric charge at rest. Basically, electrostatic comprises of two words, electro and static. The word electro refers to electric charge. And static means rest. So, electrostatic deal with the electric charge at rest. Dear student, electrostatic is all around us, whether it's the crackling sound of static electricity when you take off a sweater, the way a balloon stick to a wall after being rubbed. So before moving forward, we have to know that what is electric charge. Electric charge is the fundamental property that lies at the heart of the electrostatic phenomena. It is denoted by the letter Q. And its SI unit is Coulomb. Coulomb. Two kinds of electric charges are there. The one is positive charge and another one is negative charge. Positive charge is denoted by the letter plus Q and a negative charge is denoted by a letter minus Q. Now the question arises in our mind how these charges were developed. These charges were developed during rubbing. For example, when a glass rod rubbed with a silk cloth, glass rod develops positive charge while the silk cloth develops negative charge. Similarly, when a plastic rod rubbed with a wool cloth, the plastic rod develops negative charge while a wool cloth got positive charge. Now comes to the fundamental law of electrostatic. Fundamental law of electrostatic. Its fundamental law of electrostatic states that like charges repel each other. For example, a positive charge repel nearby positive charge, while a negative charge repel nearby negative charge. These two charges repel each other. And unlike charges attract each other. For example, a positive charge attract nearby negative charge. These two charges attract each other. This fundamental law of electrostatic can be demonstrated by an experiment in which we suspend a glass rod with a silk thread. The glass rod is charged when we bring another charged glass rod near this suspended glass rod, we observe that these two glass rods repel each other. Similarly, when a plastic rod which is charged is suspended with a silk thread and bring another plastic rod near this suspended plastic rod, we observe that these two rods repel each other. But when we suspend a glass rod with a silk thread and bring a plastic rod near it, a charged plastic rod near this suspended glass rod, we observe that these two rods attract each other. This will demonstrate the fundamental law of electrostatics, which states that like charges repel each other. That means positive repel each other, while the unlike charges, that is positive negative, attract each other. So now the another topic is properties of charges. The first property of charges is additivity. That means charges are additive in nature. For example, we have different charges of different magnitude, where that means Q1 of 1 Coulomb, Q2 of 2 Coulomb, Q3 of 3 Coulomb. So the total charge is the sum of the individual charges, that is Q1 plus Q2 plus Q3. The total charge is 1 plus 2 plus 3. That means the total charge is 6 Coulomb. So the total charge is the sum of the individual charges. So the charges are additive in nature. The second property of charges is quantization of charge. Quantization, which state that the total charge is the integral multiple of the basic charge. The total charge is the integral multiple of the basic charge. Integral multiple of the basic charge. Mathematically, Q is equals to NE, where N is equals to 0, plus minus 1, plus minus 2, etc. That means during rubbing, only the integral multiple of charges were transferred. The charges are transferred in discrete amount, not in a continuous amount. The third property of charges is conservation, which states that charges can neither be created or nor be destroyed, but it can be transferred from one body to another. Which means, for example, if we saw the conservative nature of charges, we can take one example, that is, during rubbing, when a plastic rod is rubbed with a silk cloth, an equal amount of positive charge is transferred to a plastic rod, and an equal amount of negative charge will develop on a silk cloth. So the net charge is 0 during and after the rubbing. That means the charge is neither created or nor destroyed, but it can transfer from one body to another. Another example which demonstrates the conservation nature of charges is when we ionized salt with an aqueous solution, that means NaCl. So the salt is break down into Na positive and Cl negative. During and after the ionization, the total charge is conserved, that is 0. That means the charge is neither be created and nor be destroyed. I hope you understand all the three properties of the charges. The first property is the charges are additive in nature. The second property is quantization of an electric charge. And the third property is conservation of the charge. That means the charge can neither be created nor be destroyed, but it can be transferred from one body to another. Now move to the next topic. The next topic is Coulombic law of force. Coulomb law. Coulomb law. Coulomb law of force, which states that two charges Q1 and Q2, which is separated by a distance r, the force between the two charges which is separated by a distance r is directly proportional to the product of the charges, and it is inversely proportional to the square of the distance between them. From first and second equation we got the force of attraction and the repulsion between the two charges is directly proportional to Q1, Q2, and it's inversely proportional to the square of the distance between them. Removing this proportionality sign, we got a constant, that is K. K is equals to Q1 Q2 by R square. The value of K is 1 upon 4 pi epsilon naught, and it's equals to 9 into 10 raised to the power 9. Here epsilon naught is the permittivity of free space. Permittivity of free space. Free space. And its value is 8.85 into 10 raised to the power minus 12. When we put the value of K, then we got the force of attraction and repulsion between the two charges is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. And this is called Coulomb's law of force. Thank you everyone. That's it for this class. Have a nice day.